Welcome to lesson 8.4, where we'll troubleshoot networking. It's a very common task for administrators to need to troubleshoot different problems on the network or determine where problems exist, and we have a whole suite of tools available to us. We'll examine a few of them now. One of them is ping, which you may already be familiar with, having had some network experience. It sends ICMP echo requests and wait for a response. So it's basically asking, are you up? Like, is another host up on the network? And then the other host, if it's up and configured to allow it, will say, yes, I'm up. It'll reply back with an ICMP echo reply. Very useful tool just to determining whether you have network connectivity, whether a host is available or not. One of the first things I do to check if my network is up, even on my laptop here, is I try to ping google.com and I see if it's replying. We have the trace route or trace path commands. These are used to trace the route that it's taking, that a given system is taking to get to a remote host. So when we talk about routing before, when we're examining the route tables, sometimes if the route tables aren't configured correctly, you can use the trace path command to figure out exactly what path it's taking, or you can determine if you're trying to get to some remote host and you know the remote host is up but it's not replying to your system, you can figure out where on the problem the network lies. We also have the netcat command, which is a pretty handy, very simple tool. It allows you to do arbitrary TCP or UDP network communication. So I can just send arbitrary packets over the wire to a given host at a given port. I can also set it up to listen for incoming connections. So that can be pretty useful for troubleshooting firewall problems. I could log into two separate systems and set one of them up to listen and set one of them up to send data and see if I'm sending and receiving the packets on both systems. Finally, there's the very useful TCP dump command. It puts the network interface in what's known as promiscuous mode. So it's able to investigate the network at a really deep level and tell you exactly what's going on with network packets. You can use it to troubleshoot firewall problems or to see exactly what's going on in a given network communication. In addition, there's a tool called Wireshark, which is not strictly a Linux command line tool, but a very useful tool to use in tandem. You can capture packets. What I like to do sometimes is capture packets on a Linux server somewhere with TCP dump and save them, and then copy that file to my laptop or wherever, and then load it up with Wireshark. And I can view, in a graphical format, I can view that communication. So we'll see some examples of that. For this discussion, I've just set up a really simple network between two virtual machines running on my laptop. So I have my CentOS box that we've been using all along for examples and an Ubuntu box that I've configured to have a private network. So we're using the 192.168.10.10 and 10.12 addresses. This will allow us to demonstrate some of the tools that we're going to be looking at. So let's jump into that now. So now I'm on the command line and I have two screens open. On my left is my CentOS box. We renamed it from localhost to live lesson. And on my right side I have Ubuntu. So we have the network that we depicted in the slide set up between these two hosts. We'll use that network to do some examples and troubleshooting. First things first, we'll use the ping command. I'll just ping google.com. I won't even use the Ubuntu host yet. So I sent a packet to google.com. I sent two packets, and I got replies, and I used Control-C to cancel out because we just wanted to show an example here. So it showed that the first packet was ICMP sequence 1, the second packet was sequence 2. It took 34.8 milliseconds the first time, and the second time it took 33 milliseconds. That is the measure of latency that it took, the amount of time it took for the packet to get to Google and come back. It gives us some nice statistics. I often use ping to determine whether I have a lossy network or not. I'll let a continuous ping run for, say, 500 or 1,000 packets, and then I'll cancel it out, and I'll look at these results. I'll see if I have some percentage of packet loss. Ideally, you want 0% packet loss. If you see packet loss, it always indicates that the network is not optimal. You'll often see it on wireless networks. For instance, if you're using your laptop at a coffee shop and you start a continuous ping, you'll see some packet loss. It's very common. It's less common if you're plugged into the network, if you have a physical connection. But in any case, you want this to be a very low number or percentage, especially on a server. You want this to be at or near 0. Other important information from the ping output is here that shows us the round trip time minimum was 33 milliseconds. the average was 34 and the max was 34. It shows us a standard deviation. We only sent 2 packets, so that's not very interesting, but sometimes that can fluctuate pretty widely, and if you see a large number of packets with high latency, you can usually deduce that there's some problem there. So let's try to ping our Vagrant box. Let's take a look at our network config on both of our boxes here. So on my CentOS box, I have ETH0 with this IP address and ETH1 with this 192.168.10.10 address. On my Ubuntu box, I have the same private address. This is, they're not in conflict because they're not sharing a network here. But then the other one they are sharing, ETH1, and so this guy is 10.12. So these guys can communicate with each other over a private network between the two of them. I'll start a continuous ping example from my CentOS box on the left to my Ubuntu box on the right. They're going to communicate over their ETH1 interfaces. This one is from 10.10 and the Ubuntu box is 10.12. So in order to do that, I can say ping minus capital I and the interface that I want to ping from, which is ETH1. And I want to ping to the Ubuntu box, which I know his IP address is 10.12. So that ping is running here, which is great. It means that the network is up. So now I'll just show an example. I'll bring that interface down. So I can say sudo ifconfig eth1 down, and I'm going to stop this interface on my Ubuntu box. Now notice on the left side here, I hit enter a couple times just to show it's not receiving packets anymore. So far up until that point it had been receiving all sorts of packets, and now it's stopped. So it's sending ping packets, echo requests, and it's not receiving any replies. So just to demonstrate, I'll bring it back up now I'll replace ifconfig eth1 down with ifconfig eth1 up. And instantly on the CentOS box it starts receiving replies again. I'll use Control-C to cancel that out. And we can show we got about 50% packet loss. We can show that we sent 46 packets, we received 23. So it's just telling us information that we lost some data in transit there. That's how you can use ping to determine some useful network information. Next up, let's try a trace route example. I'll type trace route, and we'll trace route to google.com from my CentOS box. So I started the trace route to google.com, and what it's doing is it's determining every hop along the path until the destination server. So it's taking some path, these are all IP addresses of remote systems, and it's telling me how long it took to get to those systems and what their IP addresses are. Sometimes you'll see stars, for instance, in this first case, and there might be others that show up here. That indicates that it wasn't able to determine what that hop was or what the latency was to that one hop. On the path between your host and whatever remote host you're tracing to, in my case google.com, it can say, well, where's the latency spike happening? What system is starting the failure? You can determine exactly where a problem along the way started to occur. So now I've cleared the screen and we'll show an example of Netcat. We can use Netcat to send and receive arbitrary TCP and UDP connections. So I'll just start on my CentOS box here. I can say NC for Netcat minus L 8000. So this is telling my CentOS box just open a connection, open a port, start listening for a new connection on port 8000. On my Ubuntu box on the right, I can say Netcat NC minus V for verbose mode, minus Z says just try to open a connection. I'll specify the CentOS box's IP address, and I'll say port 8000. So this is saying try to connect to 192.168.10.10, port 8000, and it says succeeded. So it was able to send a packet to this box, and this box stopped listening, the CentOS box stopped listening, and the connection was successful. So we know that network traffic between the Ubuntu box and the CentOS box is in place and working just fine. So we can show some additional examples. Let's look at something a little more interesting from the Ubuntu box. Like we said, it's arbitrary network connection traffic, so I can say something like echo hello world, which we know that would just print it to the screen. But if I pipe that output to Netcat, and I'll send it to the CentOS box, 10.10 port 8000, we see on the remote system we received hello world. So we sent hello world from the Ubuntu box, we echoed it to Netcat, which put it through the TCP network over to the CentOS box, which received it. So that's an example of using Netcat. Now let's look at TCP dump, which is a tool we can use to to look at in detail network traffic as it's crossing over the wire. So I'm on my Ubuntu box and I'm going to use TCP dump, and I'm going to specify -i eth1. This is specifying a very specific interface, the eth1 interface, which we know is the interface that we have a connection with our CentOS box on. And I'm going to say a filter here, port 8000. So this is saying only show me traffic that occurs on port 8000. So I just pressed enter and it's listening. So now I'm going to send some traffic from my CentOS box. So I'm just going to say echo hi and pipe it to netcat 192.168.10.12, which is the Ubuntu box, and I'm going to specify port 8000. And we have some output here on our Ubuntu box. I'm going to press Control-C, and we'll just interpret this a little bit. So the very first line of output here, we show that it's sending a TCP SYN packet, trying to establish a connection. This is coming, so it shows us the source address is 10.10, that's our CentOS box. It's sending our destination address. It tells us it's 10.12 with port 8000, just like we would expect. And then on the response here, the packet from the Ubuntu box to the CentOS box, coming from port 8000 to the random ephemeral port selected by CentOS, is a reset packet. So this is Ubuntu telling the CentOS box, sorry, I'm not listening. And then the CentOS box tries again with another SYN. And it replies, sorry, I'm not listening. So basically, the Ubuntu box is not listening on port 8000, and it's telling that much to the CentOS box. So now let's do another example. Let's listen on port 8000. We don't need sudo for this. We're going to listen on port 8000 on our Ubuntu box. And we're going to put it in the background. And now we're going to start our TCP dump again. Now let's repeat it from the CentOS box. So we're going to do exactly the same thing. We're going to send hi over port 8000 to our Ubuntu box. Okay, we got some output here. I'm going to cancel my TCP dump. Now we have some more interesting information. From the CentOS box to our Ubuntu box, the same information, and it tried a SYN packet, just the same as above. And this time, the difference is the Ubuntu box was actually listening, and it replied with a SYN-ACK, saying, yes, I'm listening. And then finally, the CentOS box completed the three-way handshake, the three-way TCP handshake, and then the conversation happened. So this would be the packet where the word hi was being sent over the wire. And then finally, we have the teardown, the FIN packets being sent. So you can see a full TCP conversation happening with TCP dump, and this is very powerful. This really helps you to debug in detail exactly what's happening on the network, and it's one of the first tools that I turn to when I'm, even for something simple like trying to determine whether a system is seeing data or if it's blocked from the firewall. TCP dump is a great tool to use for that. You can perform all sorts of fancy filters. For instance, I could say port 8000 and not port 22 and not ICMP. So this will look for anything on port 8000 but not these other ports and no ICMP traffic. Or I could say not UDP 53. So this would filter out DNS traffic, which occurs on UDP protocol port 53. So you can apply lots of filters, and there's additional flags. So I can repeat the previous example. Let's see, I will listen with netcat again. NC-L 8000, I'll put that in the background. I have my TCP dump, the same exact TCP dump example, only this time I'll add two more flags, minus little n x, little n capital X. So it's the same thing, and I'll repeat my echo to netcat example. Now look, we have a lot more information here on the right side. I'm going to cancel out of it. So most of this is kind of gibberish and it doesn't mean much to us, but importantly, we see our SYN, our SYN-ACK right here, and our ACK, and then the conversation happens. Here it is. We see our hi. So we can see the network traffic on the wire from the CentOS box to the Ubuntu box. And that can be useful to determine exactly what you're seeing on the network. You can capture this output into a format using the -w flag to TCP dump. You can write it to a file, and you can copy that file off disk and open it with Wireshark and view it through a graphical interface as well. So that was an overview of using troubleshooting Linux networks and setting up Linux networks. There are, of course, many advanced networking features out there. For instance, you can set up multiple network interfaces on a single Linux box and bond them together, known as channel bonding. This gives you improved redundancy. If one of your two network interfaces has some problem, say the network cable comes unplugged or the network adapter itself experiences a failure, which is very rare, but it happens, the second network interface will still be up and you won't lose a connection. That's an important aspect to having a high availability network. You could also use them to increase bandwidth. So if you bond two interfaces together, they have double or near double the bandwidth than a single network would have. You can use the Linux kernel to establish an IPsec virtual private network, a VPN. You can use Linux actually as a VPN server using either Strong Swan or Raccoon software. You can set it up as a full-featured router, just as nearly as powerful or just as powerful as, say, a high-end Cisco or Juniper router. You can set up an IP tables host-based firewall, which we'll see in the security lesson in some further detail. You can even set up your Linux server as a Wi-Fi hotspot. You might not need to go buy a Linksys server. If you have some system in your basement, you could just put on a wireless network card on it and turn it into a Wi-Fi hotspot. So these are all sorts of features available for networking on Linux for you.